Alright, here we are, Calculus 1.5, finding limits analytically. And I do have to say this is kind of my favorite method of evaluating a limit, although it can be a little tricky at times. So the analytical approach uses algebra or calculus. And there's three ways to solve analytically. You could just substitute in. I would always recommend just trying this first, see if it works. So for example here, if I want to evaluate what the limit is as x approaches 4, I could just substitute it right in and see. What happens? Well, x squared equals, or 4 squared equals 16. And so that would be the limit of this thing. Easy. The other way involves factoring, and the other way involves the conjugate method. I'm going to show you examples of these both real quick. Let's do the factoring one together. These aren't really meant for examples, but I'm just going to show you. We can factor this guy right here. Maybe you're familiar with the star method. It's what I usually use. Put the 8 on top, the negative 6 on bottom, and I need something that multiplies up to 8 but adds up to negative 6, and I got a negative 4 and negative 2. So this actually factors 2. X minus 4 times x minus 2. And again, that's still over x minus 2. So this is really the same thing. And actually, I should put the limit as x approaches 2 there. Now, here's what's fascinating about this method. Look, these cancel. And so you're left with the limit as x approaches 2 of just x minus 4. Well, now you can use the direct substitution method that we just used before and just plug it right in. So what happens if I just plug a 2 in here? Well, this would be the same thing as saying 2 minus 4, which is negative 2. We just evaluated the limit analytically. The conjugate method does remember that you remember what a conjugate is. Here we have the square root of x minus 4, so its conjugate would be the square root of x plus 4. So as we go to do the conjugate method, and look at this problem, I'm going to multiply by its conjugate, but I'm going to do it on the top and the bottom. So I'm going to do the square root of x plus 1, and that's inside the square root. And then since this is a minus right here, now I'm just going to say plus 1 on the outside. And I do the exact same thing on the bottom. Boom. And I'm going to do little parentheses here so you kind of see what's happening. This is really just FOIL if you think about it. This is first, right? I could do the first terms, the outside terms, the inside terms, and the last terms. Well, when you multiply by a conjugate, the rule is, or the pattern is, that you always will just take the first term and square it minus the second term and square it. I'll show you why. This is the limit as x approaches 0. Let's go ahead and just do the top. I'm just going to distribute this through. That would be x square root x plus 1 plus 1 times x is just x. On the bottom, let's go ahead and do FOIL. So let's do the first. The square root of x plus 1 times the square root of x plus 1. Well, that's a perfect square now. It's really like saying the square root of x plus 1 squared, so this is really just x plus 1. Okay, let's do the outside terms. Well, that's just 1 times the square root of x plus 1, so that's just going to be plus the square root of x plus 1. And let's do the inside. Well, that's a negative 1 times the square root of x plus 1, so that's just going to be minus the square root of x plus 1. And maybe you could see what's happening here. And then I have a negative 1 times a positive 1. That's just negative 1. See, I have a positive x plus 1 and a negative x plus 1. Well, these guys are going to cancel each other out. And so look what I'm left with. The square of the first term, and the square of the square root of x plus 1 is just x plus 1. And minus the square of the second term. The second term is 1, so I have minus 1 because 1 squared is 1. So we could simplify this a little bit. Clean it up. We got the limit as x approaches 0, x, and it might be a good idea to just leave the top in factored form. I went ahead and distributed it, but sometimes it's a good idea to just leave it in factored form. So I'm going to actually go ahead and write the numerator back in this form, and you'll see why in a second. So just write it like this. What would it look like if I wouldn't have distributed that x through? Now let's think about what I have on the bottom. Well, I have an x plus 1, and then here I have a minus 1. So I'm just going to write minus 1. Well, look, these guys cancel each other out as well. So I really just have an x on the bottom. Well, I also, when I wrote it in factored form, I had an x on top as well. So these guys cancel out. So really what I have here is the limit as x approaches 0 of the square root of x plus 1 plus 1. And now I can go ahead and do what I did before with the direct substitution. If I plug that in, that's the square root of 0 plus 1 plus another 1. 0 plus 1 is 1, square root of 1 is 1, 1 plus 1 is 2. And I have now found the limit of this thing using the conjugate method. A little bit more work, a little bit of stuff going on, but it's really not that bad. For example, I mean, I foiled here, and really, once you see the pattern, you just square the first term and then subtract that from the square of the second term. It's pretty quick. So, now you've seen a few examples, let's go on to the next page. Alright, we got a few things that we could do here. Let's do example 1 first. Just says evaluate each basic limit. Well, is there any reason why I can't just plug this 4 straight in? There's not. There's nothing where if I was to plug it in, I might get a 0 in the denominator, or I might get a square root of a negative number. Nothing like that. It's just going to equal 4. So, done. On the second one, is there any reason why I can't just plug that in? No zeros in the denominator, no negatives underneath the square root, so no, there is no reason why I couldn't do that. And so I got 16, because 4 squared is 16. That's really all there is to some of these guys. They're really that simple. Let's go on to another one. Alright, now we're looking at something a little bit more fun. Evaluate each basic limit. So this first one looks like maybe I need to factor it, but remember, I'm always going to just plug it in and see if that works. So let's just see what happens if I just plug in a 0. Well, that would be 0 squared minus 1 over 2 times 0 plus 3. Does this do anything to the problem that would make it, the limit not exist? Let's see. Well, 0 minus 1 is just negative 1. 2 times 0 is 0 plus 3 is just 3. Well, that's just negative 1/3, so it looks like we can just plug it in there. We're fine. The next one here, let's see. The limit as x approaches to 3 of this big nasty guy. Well, let's just try and plug it in and see what happens. If I just straight plug it in, I got the cube root of 2 times 3 squared minus 10. Okay, that's the cube root of 3 squared is 9, and 9 times 2 is 18. So 18 minus 10, and that is the cube root of 8. Ah, well, that's just 2. So, look at that. It looks all nasty and confusing because you got that limit sign there, but all 4 of these, all you had to do is just do direct substitution and it worked. So, that's great. If you go back to the last page with me real quick, I'll show you why we couldn't have just done direct substitution. Let's look at these ones real quick. I'll do it in blue so you can kind of see. If on the second one, if I would have just plugged in a 2, okay, look what I would have had. 2 squared minus 6 times 2 plus 8 over 2 minus 2. I should have shown you this from the beginning, but 2 minus 2 is 0, and I cannot divide by 0. That's why this one, direct substitution, did not work for this one. Same thing here, conjugate method. I'll do it right here. If I would have just plugged in a 0, I would have had 0 over the square root of 0 plus 1 minus 1. Look what I get. I get 0 over 0 plus 1 is 1, square root of 1 is 1, 1 minus 1. Well, 1 minus 1 is 0. I get 0 over 0. I cannot do this divide by 0 thing, so that's why direct substitution doesn't work. But if it does, go with it. It's fine. Let's go on to the next page. Okay, I got a couple problems here, but you may notice these are actually duplicates. These are the same ones from the first page, so I want you to just see if you could try them on your own, and then go back and check the first page and see if you did them right. Of course, you've already seen them, but just kind of see if you understand the steps. And that's it for this video. I'll see you guys on the next one.